Hey guys, Professor Doney here again, and in this little video I want to talk a little bit about distance versus displacement. Distance, displacement. Now we might want to use those terms interchangeably, but here in physics, because of going to velocity and acceleration, we need to actually define these two, and they're not always necessarily the same value. For us, distance, which is d, sometimes people like to use L, some books like to use S, is defined as how far we've traveled. Now, in our car, that is measured by the odometer, which is the numbers that dial and go across. Every mile you go, it clicks over to the next mile. It's not something that will go backwards if we go in reverse. It's not something that resets to zero unless when we get back to our starting point. That, however, would be our trip odometer. You might have one of those in your car where you can start at zero, reset it to zero for the start of your trip, and then you know how far you've gone on your trip. However, that's just for short intervals. The original odometer, the main one, is from when your car was first made to where it is now. Displacement, on the other hand, is the difference between where I ended up, my final location, minus my initial location. We might write it as x2 minus x1, x2 being where I end up and x1 being where I started. Now the book is going to write it as this, x minus x0. Now this x0 can be confusing. It's meant to be when time equals 0. So this would be at the start of our trip, this would be the end of our trip, and that would be what we refer to as displacement. Both can have units of meters, or both have feet or miles or inches, whatever units we're working in. However, they are different. Take this example. If I start at my house and drive all the way to school, that's NCC, it's about 18 miles. Okay? My distance traveled on my odometer will be 18 miles. My displacement, well, it'd be 18 miles minus the 0 miles I started would also be 18 miles. Now the only difference is if I would go, so you just pick a different color here. For work, the only difference is if I now turn around and drive back home. My distance now, I'll call it DH for home, would be 18 there plus 18 back, meaning 36 total miles. However, my displacement, which is how far from where I ended up minus where I started from, would give me 0 minus 0, or 18 minus 18, because I went there, I came back from the difference, or how far I'm displaced from where I started, which was my house, to where I ended up would be 0 meters. Now that sounds kind of silly because we did travel 36 miles, but think of it this way. If my kids wave goodbye to me in the morning as I get in the car, and then 8 hours later at the end of the day, they come back out, wave to me as I get out of the car, I may have driven to school and driven back, but they may say you got in the car and sat there all day long and then got out of the car 8 hours later. So distance is how far I've physically traveled. That's odometer, we measure how far. Displacement is how far am I from where I originally started. And if I pull out of my driveway and end up in my driveway at the end of the day, I didn't displace myself looking at those two locations. So that's how we look at the two differences between displacement and distance. I hope that helps you out. We'll have some follow-on stuff to go from displacement to velocity.